Hi, today we're going to talk on comparators and how to make them, how to realize them. Um, well, to know how to make a comparator, of course, we have to know what a comparator is. Well, the symbol for a comparator looks like this. Um, it looks quite impressive because it's got 5 connections with all the different fees, but actually it's not that sophisticated. There are two inputs, Vin and a Vref, which is called the input. The volt is an input voltage, and Vref is the reference voltage. And they've got a Vout, which is the output. So we've got the input, the reference voltage, and the output. And of course, for anything to work, it's an active circuit, and therefore we need a power supply. And this is the positive side of the power supply, and this is the negative side of the power supply. Well, what does a comparator do? Well, as the name implies, it compares two signals. It compares the Vin to the Vref. So it compares an input voltage to a reference voltage. And it works like this. If Vin is greater than Vref, higher, the output, Vout, will be equal to the positive side of the power supply. So it will be VCC. But on the other hand, if Vin is lower than Vref, the Vout is equal to the VSS, to the negative power supply. So, and of course, there's also a case in which the Vn is exactly equal to the Vref, but since there's always some noise or a small difference in between them, that case doesn't really happen. If the voltages are very, very close, the output will just flip around between higher and lower because of the noise or something like that. So a comparator makes the output high, equal to the voltage supply, if the input is higher than the reference voltage, and it makes it low, equal to the negative voltage supply, if the input is lower than the reference voltage. I'll show you that with the diagram. It's a bit more practical. So for this diagram, I've drawn the situation in which the VCC is equal to 5 volts. So that's VCC, and the VSS is equal to 0 volts. So let's see. Yeah, could be it. So what do we see here? We see the reference voltage, which is in this case a constant voltage. It could be variable, but for starters, it's better to begin with constant voltage, which is in this case about 2.5 volts. And we see the input, and the input is, it changes all the time. It will get bigger, and will get lower, and will get bigger again, and then it will get a lot bigger, and then there's some spike, and from then on it will be slowly going down. The red line is the output, and as you can see, it stays 0 volts until the moment that it crosses the reference voltage, until the input voltage crosses the reference voltage. From that point on, it will jump straight to 5 volts. It will stay high until the Vin, the input voltage, will get lower than the reference voltage again. Then it jumps back to 0. Well, that's how a comparator works, but how do we make one? Well, by far the easiest way to make one is to use an op-amp. An op-amp is, op-amp is actually short for operational amplifier. Operational amplifier, like that. And an op-amp, as you can see in the schematic, it looks quite similar to the schematic we've already seen. There are also, two contacts on this side, only one on that side, and a positive and a negative voltage supply. we look at this, well, the names are quite similar as well, because this is V out, the output voltage, and this is the positive input, or V in plus, or however you like to write it. And this is the negative input, V in minus. So if you want to use an op-amp as a comparator, it's very easy, because an op-amp is a very small and easy to use amplifier, which amplifies the difference between these two nodes with an amplification of like 1,000 or 10,000, a very high factor. So if V in is only a bit bigger than V in minus, it will amplify all the way until it reaches VCC, the positive voltage supply, and then will stay that way. If it will get lower, if the positive input gets lower than the negative input, it will go all the way down until you get the negative voltage supply. So if you want to make an comparator, the best way to use it is an op-amp. And you use the negative input as the Vref, the positive input as the normal input, and the output as the output. Well, that's how you use an op-amp as a comparator.